Alright, so this question is a word ladder. So a transformation sequence from the word beginning to the word ending using a dictionary word list. And then this is a three different rule. So you can only change one single letter per time, and it has to be within the list of the word, right? And then the beginning word does not need to be in the word list. Okay, so this is a constraint. And also when you transform, right, the last word has to be exactly the same to the end word. So what does it mean? See, so for example, one, you have hit and you have COG. How will you pronounce cog, right? I don't know. And you have the list of a word. So for the first word, you started with hit, and then you transform I to O, so you got hot. Hot is inside the list, right? And then hot transform to dot. Dot is inside the list, right? And then dot transform to O, right? You transform T to G, right? And this is it, right? And then you transfer again O to coach, right? And then this will be the M word, right? So so this is pretty much the idea. So in this question, I'm going to give you two different solutions for sure. So the first one is going to be one direction solution, and the second one is going to be two direction solution. So what does one direction solution mean? So you have beginning of word, right? And you are actually B-E-G-I-N, right? Beginning of word, right? And you are transforming the word per time all the way to the last word, so which is N, right? So you go one by one. So this is one direction, right? So what does two direction mean? So this is what two direction means. So I have a star, the beginning word, which is star, and this one is going to be N. So I'm going to transform the word one by one individually. Like this will be the set by itself, right? And then at some point they will definitely meet in the middle. So I can definitely know, okay, this time I can return true. So I don't have to I don't have to traverse all of one time. I can traverse probably a lot of them, right? And this is easier to do. So once again, so the first solution is going to be one direction. So I do need a different variable. So the first one is going to be what? So I have a list of words. So I'm going to convert to the set. So when I try to contain, which is finding, searching a word that is possibly in a word list, this is going to be cost all of one, right? So if you traverse the list of string, and then this costs all of one, but when you traverse the word inside the hash set, right, it's all of one, right? And then I do have what? And I do have a queue for the starting, so which is beginning word. And I also need another set which is going to be seen. So this is going to be what you don't want to recursively traverse the same word to another, right? So I'm just imagining. So hot, right? You traverse to lot, and then you traverse back to the hot. So in this one, you are not allowed to do this because every single word you can only use once, right? And then you want to avoid the circle, right? I mean cycle. And then I think I did pretty much the explanation. But the problem is what? For every single word, right? Hot, right? And this you probably need to what? Try 226 possibility change the word to another, right? Which is inside the list of the word, right? So you have 26 possibility, right? 26 possibility. And when you generate to another word, right, you have to push into the queue, right? So this is pretty much the solution for one direction. Okay, let's stop for it, and then I will be able to just follow along. Okay. So just once again, so the most easy solution is going to be what? If word list contains the n word, I'm going to return 0. Right? If not, so if the list inside the word list, right? If the word inside the word list does not have the word for n word, right? you return 0, right? So this calls all of them, right? Traverse. Okay. Now I need to what? I need hashtag. I'm gonna call it string. I'm gonna call it total hashtag. I'm gonna traverse the string word. So okay, so you can do like this: string word and then word list, and then you will say total add word, right? This is definitely fine, but you can also do like this. Alright, so this is another tricky solution. Now let's start with the starting queue. So I'm going to go queue, and this definitely is going to be a linked list. So I'm going to add the first word to the beginning, to the queue, so beginning word. And since this word definitely use it, so I'm going to say hashtag string sing equal to new hashtag. I'm going to put the word into the sing, right? Syntax. So now I can actually keep traversing, but before we traverse, we need to know we have to return an int, and then from here to here, right? You only have one transformation, right? And then basically that we need to have a counter, and then we're starting from 1, and I will tell you why we're starting from 1, and then we try to traverse the queue, right? And then at the end I will definitely return what? Return 0. So why do I have to return 0 over here? Because if I know that if I know the words inside the queue, right, and when I try to find out is the word is equal to the end word, then I'll just return a counter right away. If not, I'm definitely not going to return, right? So I'm going to just do like this. If size equal to what? Q.size. And I'm going to say if the word, no, not yet. So I'm going to traverse the current label queue. Right. So this is a main point. I need to traverse the current label queue. So I will try to poll. So word.q.poll. So I will say if the word equals to the end word, right? Now I will just return a counter. So I need to increment my counter right over here, right? Okay. And this is pretty much it, right? So now I need to traverse again w equal to 0, w less than word.length, right? And then w plus plus. So for every single position in the word, right? I need to know like how many possibility I can transform to another word, right? So I still need what? I'm going to say char plus equal to a, c less than equal to z, and c plus plus, right? So I will traverse the charge to word to char array. So basically, like, I need to convert the current word, right, to char array. Then I want to just change the current position to C, right? And then this is going to be changed one character only, right? This is the index, and I'm going to just convert back to the string. This is going to be charged, right? And I need to check if the word does not use it, right? If the word does not use it, and also it's inside my total. It's inside my total, and I will be able to what? Then I'll be able to push into the queue, right? And I can also what? Can also add into the set, which is for the scene, right? Then you just keep doing this, and then if you find a word that there's already inside the scene, then you just return. If not, then you just keep doing, and then until you break out the while loop, which means like the queue is empty, right? So hopefully I don't make mistake. Okay, I do. So begin words. Alright, so this question is one direction solution. So the time and space is going to be like really complex. So it's going to be at least n to the w squared. So what does n mean? N is the number of the word that you need to traverse. It's going to be all of them for the worst case. Every single word into the queue. And this is going to be what? The length of the word, right? And then this is going to be all of 26, right? And this is pretty much it, right? But you also have the 2 char, right? This is all of w, right? So all of w squared is came from here, right? And then this is 26. 26 is constant, so we don't worry about it, right? So how about the space? The space is going to be what? This is the space, this is a space, this is a space, this is a space. So it has all of n. It has all of n at this, but we have what? We have all of w again, so all of n times all of w. So this is a space, and this is the first solution. It's going to be one-way direction solution. And the second one is going to be a 2-direction solution. So I just want to remind you the 2-way direction, the starting and ending, and you just keep going one by one, and then we meet in the middle. And then for the time and space in this one is much shorter. So let's start coding. So what do I need? I still need a base case. If the word list contains the n word that's not inside, right? I'm going to just what? I'm going to just return 0. Alright, then I need a beginning hashtag and end hashtag, right? So set string. I'm going to call star, okay? New hashtag. And then star dot add the beginning word, right? And then I'm going to have another one, which is going to be called n equal to new hashtag. And n dot add n word, right? Now I also need another one, hashtag. I'm going to call string. I'm going to call total equal to new hashtag. And I convert all of the word list into the one. And using a helper function, I'm going to call BFS because it does look like BFS, right? You traverse one by one, right, until the solution. And then it's going to be what? I'm going to put a start, I'm going to put an end, I'm going to put a total, I'm going to put a count, and I will return result. So I'm just create a helper function BFS. So I'm going to just copy and paste. Star and total, and then I will have a step, right? So I'm going to just keep traversing based on the star. So when the size of the n is greater than the star, I'm going to swap. So I will just keep focus on the first argument hashtag. So if star size is less than the n if it is greater n size, right? I do the swap, right? So return BFS and star total set. Right. So now I need to so just think about this. If star is like the first word and then the n is only has the first word as well, right? So we don't come to here. We need to check the the possible word you can generate, right? So I'm going to say hashtag. I'm going to call a string. I'm going to call attempt, right? And equal to new hashtag. And then I need to remove. Total have to remove. So I have to remove the beginning set, which is a star, right? Because I no longer need a space and then time to just searching over, right? But I do need what? I do need to traverse the word inside the star. So even though you remove from the total, but you can still traverse the hashtag star, right? Now I need the index, right? I less than s dot length and I plus plus. So this is the every single word precision, right? Index, right? And then I would definitely need a chars array. I'm going to say chars equal to what? S dot to char array. And then I need what? Chars equal to a, like convert the word to what? Convert the character, sorry, to another single letter, right? So So you might be able to know why I do have to generate a source array over here, because for every single index, you need to generate back to the original one. So when you want to put it right over here, right? When you change the index based on the C, right? You are not going to change it back unless you put it at the end. But what happens if you just do like this? This is more easier to read and code, right? And I would definitely say, okay, char I is in I position, right? It's going to be C, right? And I'm going to say the new word is going to be based on this, right? And then I would say, okay, if the total does contain the new word, right? I will have to just add to the 10. But I'm not finished. If the total contains the new word and also thus contains the new word. So what does this mean? I always traverse the starting, which is a star hash set, right? And then somehow it's already inside the end hash set. So which means they are interface, right? They actually meet each other, right? So I can just say return step plus 1. So the reason why you need to plus 1, this is because you haven't reached the word yet. You need one more step. So when do we need to increment our step? It's right over here. Why? Because for every single word you can possibly change one character at a time, and this is changing the position, right? Looking for the index, and then you're still in the set, and then once you finish, this is going to be you change one character for the word, and then if a 10 is empty, which means you are not going to just add a new word into it, right? So you finish the for loop, and then okay, the attempt is still empty. Then I know this is going to be what? This is going to be return 0, right? You are not allowed to find a new string of word for two hash sets, right? One is for starting, one is for ending, right? And everything else, right? Everything else, if you can find it, and then you want to just keep traversing based on the attempt hash set for the start. So I'm going to say bfs attempt, and then end, and then total, and then step, right? We already increment by 1. We don't have to increment over here. So step. Right, let me submit. So yeah, this is definitely much more easier to read. So let's talk about the time. This is going to be all of them, right? So the worst case is going to be all of them, but not finished yet. So this is going to be the word, starting word. So the worst case is definitely all of them, right? You traverse every single one until the end, right? But I'm not going to say that. This is because if you put a word into the attempt, and then you will just increment by 1, right? So beginning you have 1 only. Beginning you have 1, which is starting, and this is ending. And then once you add another word into it, right? So this one will generate, right? So this one will generate. I mean, this one will get notice. Oh, the starting set is definitely greater than ending set. Now you want to swap, so you swap this. So ending with the starting. So you are changing the hash set, right? So this go by 1, and then you want to go this by 1, right? So I would definitely say this is going to be what? At least. This is definitely going to be all of them, right? This is going to be definitely all of them. And this is definitely going to be all of the W, right? W. And this is 26. Right? So yes, so it's going to be all of W, all of n times W. So I'm not sure, but this might be my time complexity. And for the space, it's going to be definitely the same thing, although n times w. So the reason why is because the headset. So the headset, you can generate a word, a lot of word times, right? So this is my two-way direction time and space complexity. You might disagree with me because I'm not 100% sure, but this is the solution. So if you have any question, leave a comment below and subscribe if you want it, and I will talk to you later. Bye.